Hello my dear friends, a very good morning to all. Hope you all are fine, and Corona is spreading very fast now, so please take care of yourself and your family. Regularly hand wash, and please wear always when you are going outside or when you are in front of someone, and please wear face mask. Okay, so please take care of you all, and let's do. So in the last class we discussed about some interesting problems regarding superposition as well as intelligence theorem, as well as reciprocity theorem, right? Reciprocity theorem. So now we are going to discuss about intelligence theorem. I actually regarding intelligence theorem, I just mentioned what is intelligence theorem is, and I didn't go into deep, I think. Okay, so let's do some more. Let's move to more detail what is intelligence theorem is. Okay, and you will definitely feel what it is. Okay, so let's see first what is intelligence theorem is. I already explained. I already mentioned, but not in detail. But now we will go into deep. So intelligence theorem states that in any circuit, the peculiarity of intelligence theorem is that in any circuit means this theorem is applicable to both active and passive network, unilateral and bilateral network, and linear or non-linear network. Non-linear or linear network. For all of these circuits, this theorem is valid. That means it is a universal theorem, right? Universal theorem. All the theorem, active or passive, unilateral or bilateral, linear or non-linear, etc. This is actually an expanded version of what energy conservation principle like that. Okay. So according to intelligence theorem, in any circuit, that means active or passive, unilateral or bilateral, non-linear or linear, in any circuit, the algebraic sum of the powers is equal to 0. Algebraic sum of the powers equal to 0, which means for active source, suppose this is an active source. This is an active source which is delivering power. So delivering power or P deliver is taken to be negative. I already said that P deliver is taken to be negative. Or in some other cases, you may notice a circuit like a part of the branch, a branch of the circuit diagram like this. This is current I, then this is V, which means here the voltage source V, this is absorbing the current I. So anything which absorbing current means means P absorb, P deliver or P absorb. P absorb is always positive. Is it clear? And when you discuss with either R, or either L, or either C, all are what? Passive, right? All are passive. Passive elements, right? For passive elements, I already said that for all passive elements, what is that? P will be absorbed in nature and it will be positive. So the value of the power will be taken to be negative if it is delivering power. The value of the power to be taken to be what? Positive when it is absorbing power. For R, L, C, all are passive elements. So of course we know that for passive, positive. I already said that for passive, positive power. Okay. So according to intelligence theorem, the algebraic sum of the power in a circuit is 0. Let's check with an example. Okay. So let's check with an example. Consider see, it is 20 volt. It is 5 ohm. Let it be 5 ohm. So this circuit contains what is that? A voltage source, a resistor, a group of resistors, 5 ohm each. Then what is the current here? Total current I here. What is the total current I here? Total current I is nothing but, what is that? This 5 and 5 no, parallel no. This 5 and 5 are parallel. Again it is series with this 5. So it will be 20 divided by 7.5, right? Am I right? 5 plus 2.5 is equal to 20 divided by 7.5, right? So it will be 200 divided by 75. So cut with 5. So it will be 8 by 3 ampere, right? So our I will be what? 8 by 3 ampere. Our I will be what? 8 by 3 ampere. So this is total current 8 by 3. And what will be this current and this current? This is 8 by 3 means, this is 8 by 3 means, this will be what? 8 by 6. Because half of the current will flow here and again half of the current will flow here, right? So it is 8 by 6 and 8 by 6. And now we are going to verify intelligence theorem. Okay? So listen. Okay, listen. So P deliver, total sum of the, algebraic sum of the total power will be equal to 0. That means P deliver plus P absorb equal to 0. That is the meaning of what? Algebraic sum. Algebraic sum means P deliver plus P absorb equal to 0. So now what is P deliver here? What is P deliver here? P is nothing but voltage into current. That is V into I, right? Power is nothing but voltage into current. Or we can say that P deliver will be equal to 20 into what is current? 8 by 3. 160 by 3 watt. Unit of power is nothing but watt, right? Unit of power is nothing but watt. So 160 by 3 watt. Is it correct? Okay. And what is the power in 5 ohm? Power delivered in 5 ohm. Power absorbed in 5 ohm, or simply P 5 ohm. P 5 ohm. And this is nothing but negative in nature. Now I already said that P deliver will be what? Negative in nature. P deliver will be negative. So similar will be negative in nature. So 20 into 8 by 3 is negative in nature. And what is the power across this 5 ohm? Power across this 5 ohm is nothing but, what is that? I square into 5. Right? Power P is nothing but I square into R. So it will be 8 by 3 the whole square. 8 by 3 means 64 by 9 into 5. Is it correct? So what is 64 into 5? 320. 320 by 9 watt. So that is P across 5 ohm. This 5 ohm. What is P across this 5 ohm? What is P across this 5 ohm? This 5 ohm. Let be P dash. Let be P dash. What is this 5 ohm? It is I square into R. That is 64 divided by 36 into R watt 5. It is nothing but 64 into 5, it is nothing but 320, right? 320 divided by 36 watt. And what is another 5 ohm? What is another this 5 ohm? That will be P double dash. This 5 ohm. Power across this 5 ohm. What is that? Again 64 divided by 36 into 5, right? 64 divided by 36 into 5, right? So it will be again same 320 divided by 36 watt, right? So now you got 3 powers absorbing nature, right? 3 power all are absorbing, that is why positive, positive, positive. And algebraic sum means the total power. That is P deliver plus these 3 sums. P deliver plus these 3 sums will be equal to what? 0. Let's check. Or let's check in other words, these 3 will be plus 160 by 3. That also right. If you check for these 3, when it total sum is equal to 160 by 3, let's check. Is it correct or not? That means P 5 ohm plus P dash 5 ohm plus P double dash 5 ohm equal to, what is that? 320 by 9 plus 320 by 36 plus 320 by 36, which is nothing but 320 by 9 plus 2 into 320 by 36, right? 320 by 9 plus 320 by 18, right? Correct? Is it correct? So it will be equal to 320 common 1 by 9 plus 1 by 18. So it will be 320 into divided by 18 into 9, right? 18 into 9. When it comes, it will be 9392 to 160. So it will be 160 divided by 3. Is it correct? Is it correct? 160 by 3. 169 in 932. Again 3 is there. So 3 into 3, 4 cancel. Yes, correct. And it is 160, right? 160. Correct. Is it correct? Is it correct? 27 divided by 18 into 9 into 320. 27, 9, 3 and 2. Correct. Correct. Okay. So 160 by 3. That is plus 160 by 3. So see, the power delivered equal to minus 160 by 3. The total power absorbed is equal to 160 by 3. Total sum will be equal to 0. That means power delivered will be equal to power absorbed. Simple. So that is the concept of intelligence theory. That is the concept of intelligence. Okay. So the peculiarity or speciality of the intelligence theorem is that it can be applicable for both linear, non-linear, active, passive, unilateral, bilateral. Every circuit can be applied. Every circuit it can be, because it follows in an indirect manner the energy conservation principle. Because energy conservation principle is everywhere you can apply that. Everywhere you can apply that energy principle, energy conservation principle. So this theorem is what? A vital theorem, because it is a universal theorem, or in other words. Is it clear? Is it clear to you? Is there any doubt? Okay, it's simple actually. It's very simple. I just mentioned, because in one word question, these session will be important. Intelligence theorem is applicable for this, no, or not applicable to this. Find the correct statement, or like that. You may expect like a question. Find the correct statement from the below options. No, because maybe there is a chance of question like this in SSC, like examination. Is it clear? Is it clear? Okay. Let's move to next session. Let's move to next section. Let's move to next session. Next, substitution theorem, very, very important. Substitution theorem. See, consider into what? Consider into it. So substitution theorem states that, see, this is equivalent to what is the current through this circuit I? What is the current through this simple circuit I? This I is nothing but 36 minus 18 divided by 6, right? Which is nothing but 18 by 6, or I is equal to what? 3 ampere, right? I is equal to what? 3 ampere. Or the same circuit you can represent it like a very interesting theorem and a very useful theorem in problem solving. Okay, see substitution theorem. So the meaning itself reveals something, no? Substitute, you can substitute instead of something, right? That is the meaning of substitution theorem. So what it is? Consider a simple network 36 and 18 volt, okay, which is connected across resistance 6 ohm. So the current through this circuit will be nothing but the difference in potential divided by the resistance, right? So it will be 36 divided by 6, this is nothing but 18 by 6, and it will be 3 ohm. You know that 3 ampere, sorry, 3 ampere. You know all this. So the same circuit can be represented like a 36 volt, keep black like that, I mean keep that 36 volt like before, so there is a 36 volt, 6 ohm like before, that is 6 volt, there is no change in that. The total current is 3 ampere now. The total current through the circuit is nothing but 3 ampere, right? The total current through the circuit is nothing but what? 3 ampere. So it will be 3 ampere. So there will be initially a voltage of 18 volt here, no? There will be initially a voltage of 18 volt, no? 18 volt, no? So this 18 volt can be represented like a resistor of magnitude 6 ohm, so that the 3 ampere current when flow through it produce a voltage of 6 into 3, that is nothing but 18 volt. So that means, in simply, if a circuit contain a voltage source or so many voltage sources, any one of the voltage sources can be simply represented like a what? A resistor in series with a current, and the voltage will be again 18 volt. No, there is no issues in there because there is no change there. See, the drop across the 6 ohm will be 6 into 3. 6 into 3 is nothing but 18 volt. So 18 volt. There is no change. So these voltage source can be represented like this. These voltage source can be represented like this. So for calculation purpose, no, for simplicity of calculation, sometimes you may have to change. You may have to change the what? Voltage source in terms of resistance. When we are doing some problems, it will be very much clear to you. Okay, so until then wait. When we are doing some problem, it will be definitely clear to you, more clear to you. Okay, so this is the concept of substitution theorem. And now I am going to take maximum power transfer. I have already explained that maximum power transfer theorem. Special cases. Maximum power transfer theorem, special cases. So I already said what is maximum power transfer theorem is, that means suppose a circuit contain, so any circuit can be represented a voltage source in series with a resistance, that is V Thevenin, and series with the R Thevenin. This V Thevenin sometimes called Vs, Vs, source voltage. This R Thevenin sometimes called Rs or what? Source resistance. Both are same, no? Sometimes it is represented, no? In examination you may see simply Rs sometimes, you may see R Thevenin sometime. Both are equal. You may see V Thevenin sometime and you may see Vs sometimes. Both are same. So V Thevenin or Vs same, R Thevenin or Rs. That is Thevenin's resistance is nothing but source resistance. Thevenin voltage is nothing but source voltage. Suppose this is a circuit, no? If this is a circuit which contains DC, only DC, DC source and a resistor RL. Since it is DC, all these elements will be resistance in nature, right? There is no influence of inductance or capacitance there. So because it is purely DC, we are dealing with the DC circuit. So we already studied that when a flow of current IL through the circuit RL, that is the load, then maximum power transfer or PL max will be equal to V Thevenin square divided by 4 into R Thevenin. And maximum input power P input max will be equal to V Thevenin square divided by 2 into R Thevenin. And maximum efficiency will be equal to what? 50% or 0.5. So these are the terms we already studied, no? These are the terms we already studied regarding DC maximum power transfer theorem. Now we are going to extend this theorem to AC circuits. Now we are going to extend the theorem to AC circuits. That means there is not at all only what RL, there will be inductor or there will be capacitance also. So now we are going to do what? We are extending our maximum power transfer theorem to AC. To AC. So see. So this is we already studied, and see for AC. Maximum power transfer theorem for AC circuits. For AC circuit, a represent like Vs or V Thevenin, no, there is no issues there. And instead of this RS, there will be ZS. And instead of this RL, there will be ZL. IL is diagram. And IL is diagram. So this is the, and instead of this DC, there is AC. There is AC. There is AC. See, so for AC circuit, when we are dealing with maximum power transfer theorem, our circuit has been changed. Our circuit has been changed into what? Vs as AC, Zs. No, instead of this Rs or R Thevenin, it will be Zs, and ZL will be what instead of this RL. And this Zs is nothing but what? Zs is nothing but source impedance, right? And which is nothing but Rs plus jXs, right? Rs plus jXs. And ZL is nothing but what? Load impedance, right? Which is nothing but what? RL plus J into XL. RL plus J into XL. And Vs is nothing but what? Source voltage or Thevenin voltage. Both are same, right? Thevenin's voltage, both are same. So the circuit can be changed to this manner. That means Vs, Zs and Zl. Okay. So what is the value of IL here? What is IL here? IL is nothing but, listen, Vs divided by Zs plus Zl. Zs plus Zl. Is it correct? Vs divided by Zs plus Zl. Or in other words, which is nothing but Vs divided by Am I correct? Am I correct? Or which is nothing but is it correct? I simply grouped Rs together and J terms together, nothing. Rs plus RL plus J into Xs plus S. So this is nothing but IL. This is of course it will be what? No, it contains real plus imaginary terms. So it is a vector, right? It is a vector like situation. So what will be mode IL? What will be modulus of IL? Because it is no R divided by like term, no. So what will be mode IL? It is nothing but Is it clear? Is it clear? So this is in vector form. IL will be equal to, there will be some real term and imaginary term. So it will be vector matlab instead of, that means simply a complex term, right? Vector or complex term. Vector or complex term. Vs divided by Rs plus Jx is a complex term. So if you want to take the modulus, take the modulus of numerator plus take the modulus denominator. Modulus of numerator means root of Vs square. Root of Vs square is nothing but Vs. And modulus of denominator means real term square plus imaginary term square, right? So real term square is Rs plus Rl the whole square. Imaginary term square is Xs plus Xs the whole square. Is it correct? Is it correct? So that be equation number 1. That be equation number 1. So this is the load current which is flowing in an AC circuit. AC circuit. Okay. So let's check some cases here. Let's check some cases here. Let's check some cases here. Case 1. RL is variable. RL is variable. That means, suppose this is the circuit in which we are varying RL only. RL is nothing but the component in ZL. No, the component in ZL is nothing, is the RL. RL, this term. Suppose you vary RL only, then what will be the effect of what maximum power transfer? That we have to check. Okay. So when RL is variable, we know that PL will be equal to, that is the power through this load, power across this load will be equal to IL square into RL, right? If RL is variable, then RL is the variable, no? So IL square into RL, IL square into RL, because power is dissipated across this RL only. That is why IL square into RL. And this IL square is nothing but what? Vs square divided by this one. Because the root goes out now. If you square this, the root will goes out. So I mean it will vanish now into R. Into R. Is it clear? So it will be equal to whole divided by or simply simply like that. You don't need to expand all this, simply you keep it like that. Okay. So this is nothing but PL. This is nothing but PL. For getting maximum PL, dPL by dRL will be equal to what? 0. Is it correct? For getting something maximum with respect to someone or with respect to something, what we are going to do? We are going to do dPL by dRL equal to 0. Nothing. Simple mathematics we already studied. Regarding DC maximum power transfer theorem also we studied the same thing. dP divided by dRL or dP divided by dRL equal to 0. So same thing you can apply here also. So it will be dP divided by dRL equal to 0. That means differentiate this term and equate it to 0. Differentiate this term means denominator into d by dt of numerator, right? Which implies denominator, which is nothing but Rs plus RL the whole square plus Xs plus XL the whole square. Denominator into d by dt of numerator. D by dRL of numerator means it's simply Vs square, right? Minus numerator into d by dRL of denominator. D by dRL of denominator is nothing but 2 into RL plus Rs, right? Correct. Nothing but 2 into RL plus Rs. Simple. Whole divided by Rs plus RL plus Rs the whole square plus Xs plus XL the whole square divided by denominator square, no? That means if you have to differentiate numerator and denominator, if in both are, it contain variables of differentiation, the differentiation result will be denominator into d by dRL of numerator minus numerator into d by dRL of denominator whole divided by denominator square. That is the equation. So it will become like this, which is equal to what, beta? 0. Which is equal to 0. So I am going to rub this. So it will become implies, that is, the denominator goes there and it will be always 0. No need to write again. So it will be into V square equal to 2 into RL plus RL, right? 2 into RL plus RS, right? 2 into RL plus RS, right? It is 2 into RL plus RL, because this RL and RS, it contains 2, no? So I simply write 2 into RL. So it will become 2 into RL and 2 into RL RS, right? 2 into RL RS, correct. So it will become 2 into RL RS and 2 into RL RS got cancelled. No need to write this. And this is cancelled. And the remaining term will be, what is that? RL will be equal to root of RS square plus XL plus XL the whole square. Is it correct? So this is the condition for when we vary RL only. So this is regarding AC. So the chances of maybe no question like this will be very few. I mean, chances will be very less. But you can expect. Not always we are dealing with the DC circuit all the time. Sometimes you may dealing with the AC circuit also, and there also you have to apply maximum power transfer theorem. So the condition for maximum power transfer, the condition of the load RL for maximum power transfer will be RL will be equal to R square plus XL square, which means under this value only maximum power transfer will happen in an AC circuit. That is the meaning simply. That is simply the meaning. Under this condition only, that means whenever the RL value will be equal to root of RS square. RS is nothing but a source resistance plus XS the whole square. It is nothing but inductive reactance of load and source square. When RL satisfy or when RL equal to this value, there will be maximum power transfer in a AC circuit. But in the case of DC circuit, there was no need to think of it, right? There was no need to doubt and all, because when RL equal to R Thevenin, when RL equal to RS only, no? When RL equal to RS, root of RS square means it is simply RS. So regarding DC, when RL equal to RS, maximum power transfer will happen. But in the case of AC, it is not simply RL equal to RS or RL equal to R Thevenin, but RL will be equal to RS square plus XL plus XS the whole square. Is it clear? So let's move to case 2. When XL is variable, So in the first case we discussed when RL is variable, we are only varying RL, then what will be the condition for maximum power transfer. Next we have to see when we are varying XL, that is the load inductive reactance. There may be circuits like that also. There may be circuits where we can vary what XL instead of RL. There may be circuit like that. So in that circuit, what will be the condition for maximum power transfer? That's we are going to do. For that, dPL divided by not dRL but dXL equal to 0. Is it correct? For getting RL is, if RL is variable mean dPL divided by dRL. For XL is variable mean dPL divided by dXL equal to 0. So let's differentiate taking. So it is nothing but where is our PL here? Yes, this is our PL. So we can convert this, right? We can take differentiation of that. Okay. So what is that? Again, denominator into that is equal to, which implies RS plus RL the whole square plus XS plus XL the whole square. That is nothing but the denominator, right? Denominator into d by d XL of numerator is, there is nothing in numerator, no? There is no term in XL in numerator, so it will be 0. Minus numerator into, that is Vs square into RL into d by dxl of denominator. So this will be 0 and only this will be happen. 2 into xl plus xl equal to what? Divided by whole divided by what? Denominator square. Rs plus RL the whole square plus XS plus XL the whole square equal to 0. This is the condition. Denominator into d by dxl of numerator minus numerator into d by dxl of denominator whole divided by denominator square. Denominator square equal to 0, nothing. Equal to 0, nothing. So this goes to 0. This is also 0. It is simply what it implies: Vs square into RL into 2 into XL plus XS equal to 0. Or simply you can write XL equal to minus XS. XL equal to minus XS. Nothing but XL equal to minus XS here. So this is the another condition. So whenever you vary XL, maximum power transfer will happen when that XL value equal to minus of XS value. Minus of XS value. XS is nothing but a source, reactance, no? Source reactant. We can't vary that. So whenever that XL equal to minus XS, when we vary the inductive reactance or XL, maximum power transfer will happen. So what is the meaning of all these? No, you not need to confuse or you not to what hit on up your brain. No need of that. You just what? Imagine the situation. Imagine the situation. We gave an AC circuit. So okay, AC supply to an AC circuit. Clear? If we vary RL, then when maximum power transfer will happen? So maximum power transfer will happen when the value of RL equal to root of R square plus RL plus XL plus XS the whole square. Next thing, when you vary XL, maximum power transfer will happen at what? At what condition? So when XL equal to minus XS, maximum power transfer will happen. Is it clear? Next case. I know it is difficult because it contains derivation, no? But you have to remember only the condition. This condition only you have to remind. So case 3, RL and XL vary. If you vary both RL and XL, what happen? No, we have an equation for vary. Suppose we vary RL is nothing but R square plus XL plus XS the whole square, right? R square plus XS the whole square, right? For vary RL only. If you vary XL only, XL will be minus XS. So substitute XL equal to minus XL here only. So RL will be equal to what? Root of R square into plus XL equal to minus XS. So minus XS plus XS whole square. So it will become 0. So simply RL equal to RS, which is nothing but similar to DC condition. DC what power transfer, right? RL equal to R Thevenin. So you have to remind these three things. So first thing you have to note when the circuit given to you, whether the circuit is AC or DC. First you have to check that. If it is DC, no, go directly for V square divided by 4 R Thevenin, and input will be V square divided by 2 R Thevenin, efficiency will be 54, no doubt in that. If you are given a DC, not a DC, an AC circuit. If you are given an AC circuit, then you have to think like it. That means you have to think of whether RL is varying, whether XL is varying, whether both RL and XL is varying. Then only you have to apply for these conditions. That is you have to think. Okay, so you have to observe very thoroughly that whether the circuit is given in AC or DC in nature. Okay, let's check the time. Okay, time is there. Is it clear to you? So you have to remind these three conditions only. Condition number X, condition number Y, and condition number Z. You have to remind these three conditions only. This is very important. No need to remain all the derivation and all. No, for understanding purpose only I did the derivation, but you have to simply look these three conditions, x, y and z conditions. Is it clear to you? Okay, that's all. How do you feel about electrical circuits? How do you feel about electrical circuit? Is that all you studied in your beta classes? No. They studied but in different manner, right? But in different depth also. But competitive manner, and for a competitive examination, this is sufficient. This is sufficient. So that is the main thing, no? The difference between the theory session that we already studied in BTech during that 4 years, no? During those 4 years, and we are now we are going to complete the whole 4 year in 6 months. So many portion will be we need to avoid many portions, and we focus only for some areas, thrust areas, no? Then it will, the exam will be very easy. Is it clear? So let's do some problems. Okay, write a question. See, many questions in your examination like this. Determine the value of RL such that determine the value RL such that maximum power transfer to RL. Maximum power transferred to RL. See, we have to find the value of RL now. It is given that maximum power is transferring to RL. So what is the condition? Which equation we have to use here? See, this is absolutely an AC circuit, right? So there are conditions like when RL is varying, XL is varying, and both RL and XL is varying. So clearly indicating in the question itself that the RL is varying because maximum power is transferred to RL. So RL is varying. So let's see what was the condition for when RL is varying. When RL is varying for maximum power transfer, when RL is varying, that RL value will be equal to root of R square plus XL plus XS whole square, right? XL plus XS the whole square. That is the condition. Is it clear? So RS is nothing but 10 ohm. It is given. XS is given as 3 Henry. There is no XL. So XL will be equal to 0. So XL equal to 0 and XS will be L omega, which is nothing but 3 into omega is nothing but 2 pi into F. Frequencies was 2 pi L omega. Directly you can go for L omega. No need. L omega. So it will be 3. Omega is nothing but 2. 6 ohm. XS equal to 6 ohm. XL equal to 0. So directly apply there. RL will be equal to root of RS square 100 plus XL plus XS the whole square, that is equal to 36. So XL will be 0, XL will be 36. So it will be root of 136. This is the value of RL for maximum power transfer. I think it's clear to you. I think the concept is clear to you, right? Okay. Is there any doubt? See, the problem is very easy after we did the derivation and we found the conditions. without knowing that condition and all, try solving this problem is difficult, no? In your examination, a problem may be like this also, The answer is two-step. But reaching to that level of two-step is very, very important. Very, very important. You have to think a lot. Is it clear? Okay. Let's move to another problem. See, beta, I am starting from very, very basic level, no? Very, very basic. Maybe my classes are very slow, I know that. But it's for making you understand. Otherwise, things will be very difficult for you. Okay. Let's check on another question. Not very, it's simplest. It's not very. Yeah. Find maximum power transfer across R. Maximum power across R. Maximum power across R. B, value of R such that maximum power occurs across across 3 ohm. So these two things you have to find. Okay. See the question carefully. Observe the question carefully. How can it be solved? See, by first look itself you can find that this is a DC circuit. No, the source is DC. So only equation in our mind will be power output, maximum power will be V square divided by 4 R Thevenin. Input power will be V square divided by 2 R Thevenin. Efficiency will be 50%. These three things you have to keep in your mind for DC circuit. So first value, maximum power across R. We have to find the maximum power across R, which means it is not necessary that always we have to calculate maximum power at one end. No, load may be this value, load may be this value. That's my convenience. It need not be all the time to one end. No. There is a convention that always we have to calculate power across 3 ohm, load across 3, current across 3 ohm. That means we consider these 3 ohm as the load all the time. It's wrong. Sometimes there may be load here also. It's my convenience that where I have to place my load. It's my convenience, my wish that where I have to place my load. It need not be all the time at the one side. It need not be all the time. That's you have to check. Is it clear? Okay. So maximum power across R. That means we have to find the maximum power across R. So first step itself is that. No, maximum power transfer. We need the maximum power transfer equation. P max will be equal to, or simply PL max will be equal to V Thevenin square divided by 4 into R Thevenin, or Vs square divided by 4 into Rs. Both are same. So now you have to find V Thevenin and we have to find R Thevenin. So for find V Thevenin, what is the step for finding V Thevenin? Remove that resistance and find the open circuit voltage across that resistance. That means my circuit will become for V Thevenin, my circuit will become So this is my circuit, right? I have to find the open circuit voltage across that R. That is my V Thevenin. So open that terminal R and keep the element remain as such. Make the voltage source as like and find the value of V Thevenin. So simply you can apply for voltage division rule now, because it's series circuit now. You can apply for voltage division rule. So V Thevenin will be equal to what? V Thevenin will be equal to 20 into 6 divided by 6 plus 3, 9, 3, 2, 3, 3. 60 by 20 volt, right? Is it correct? Is it correct? Is it correct, beta? No. Mogaranda. Oh my god. Simple calculation now. Let's check. It is 20 into 6 divided by 6 plus 3, it is 9. So when cut it to 3, 3, 2, 3, 3. So 40 by 3. Right? So 40 by 3 volt is the Thevenin voltage. Right? And next step is finding R Thevenin. For finding R Thevenin, what was the step for finding R Thevenin? What was the first step for finding R Thevenin? Keep the open circuit terminal as like this and observe from that region what is the total resistance, such that all the independent sources should be switched off and dependent sources should be as such before. Right? Here only one independent source, that is nothing but 20 volts, so that to be short circuited, and R Thevenin will be right. So this is R Thevenin. That means you have to find the resistance between these two terminals, which is nothing but 6 and 3 make parallel. So R Thevenin will be what? 6 and 3 is parallel, is nothing but 18 by 9. Nothing but 2. Nothing but 2. Clear? So maximum power will be V Thevenin square divided by 4 into R Thevenin. So it will become, what is that? V Thevenin square is nothing but divided by 4 into R Thevenin is nothing but 2. Correct? So it will become 200 by 9 watt. Let's check the answer. Correct. 200 by 9 watt. Is it clear to you, beta? Is it clear to you? So this is the answer for A. And next see, value of R such that the maximum power across 3 ohm. There are options. 1 ohm, 2 ohm, 4 ohm and 6 ohm. There are options also. This is options. There are options also, 1 ohm, 2 ohm, 4 ohm and 6 ohm. So you have to find value of R. That means this value of R. This R, what is R value? Such that maximum power across is 3 ohm, not across R ohm. Maximum power across 3 ohm. Maximum power across 3 ohm means, suppose this is the load current IL, then I can write like PL across 3 ohm maximum, like PL max across 3 ohm. PL max across 3 ohm equal to, what is that? IL square into 3. Correct? IL square into 3, right? I square into R will be maximum power. And IL is nothing but 20 divided by is it correct? Is it correct? Into 3. Is it correct? IL will be voltage divided by total resistance. Total resistance is nothing but 6 parallel to R. 6 parallel to R plus 3, that is the total resistance. 6 parallel to R plus 3 is the total resistance. For maximum PL, this denominator term, no, denominator term, this will be minimum, no, this will be minimum, no, for maximum PL, this will be minimum, no, this will be minimum means 6 parallel to R will be minimum, correct? Denominator minimum means 6 parallel to R also minimum, right? 6 parallel to R also minimum, right? 6 parallel to R means minimum means implies 6R divided by R plus 6. 6R divided by R plus 6 is minimum, right? Is minimum. So from the option, what is the value of R such that the whole expression will be minimum? Simply it is 1 ohm. When you substitute 1, then only this expression will be minimum. See the level of question. See, when you are dealing or when you are preparing for such type of examination, you have to be up to a level. Then only the below levels questions will be easily you can answer. That's why I am going to do all this. Because in the circuit theorem, no, this is all SSC range questions. So definitely you are, if you are preparing for that, no, RRB JE also, the question will not be this level. Only SSC will be covered up to this level. So I am going to make you to that level. Then the below level exams will be very clear to you and very easy for you, and you definitely will crack. There is no doubt in that. Okay, let's check the time. Okay, so that's all for today. So let's continue our session on tomorrow. Okay, so until then, thank you and stay safe always. Okay, so please share my video. If really like the content, please share to all of your friends, and please don't wait for confirmation date until confirmation date come, because for covering the whole electrical subject at least you need 7 to 8 months. I repeatedly saying it is 7 to 8 months. Continuous effort will be there in order to crack the complete, in order to cover complete syllabus. So don't wait until last moment. Okay, so try to learn from this time on. From this moment you have to study. Okay, so please study well, revise well. Okay, so let's meet in the next class. Okay, tata.